of Chapter 3. This section is, we're going to start with 3.2, typical and central values. So if you remember from last time, we were looking at data and how to um, put it into a picture or illustrate it so that we could make some sense out of it and be able to say, well, what does this really mean to us? Or what does it really mean to my supervisors who I'm trying to help explain the data information to? So that's what we're looking at. Um, but we're going to look at a large quantity of data, more of a large quantity of data. And we know that if we simplify it down to one value, when you have this huge amount of data, that it might not, it won't be as helpful or informative. It might tell you something, but we kind of want to look at what makes the most sense. So we look at different things. We can look at grade point average as a measure of your overall academic performance. If you're looking at your bills, you could look at your monthly electric bill, typical home prices, things like that. Um, so we'll look at those different things and we'll talk about them and see what makes sense. We're going to be talking about typical values within a set of data. So we will look at the mode, the median, and the mean. Now, remember that as we go along, some of these or one of these might make more sense for the data than others. And so we have to take that in consideration. One thing that I can think of from an example from years ago when I was teaching this class, a class similar to this, was where you have this group of salaries for NBA players. And so you would have all these salaries and you'd have some here and some here and some way up here. And when you have ones that are way up there for these really high performing players, it's going to skew or move that data in a way that you might not want it to move or might not expect it to move. And so looking at the other measures can help you to make more sense. And if you do end up using that one point, you can say, oh, yes, well, we use this, but we know that it's really skewed over here or looks higher than it is because there's some people out there who, they're really good. They're stars and they're making a lot of money. So that's something to look at. So we're first going to look at the mode. And the mode is the value that occurs the most in your set of data. So you're looking at a set of data. What number, what color, what category comes up the most? Okay, so we talk about that. So you could have in this big set of data, you never know, you could have one mode, and that would mean that that is the only one that occurs most quick frequency. So that's also called unimodal. Unimodal, meaning one. And so that would mean there would be one mode or one number or category that comes up the most. And we're going to look at this. But for example, you know how we looked at the grades? A, B, C, D, F, and we looked at how many times each occurred. The one that occurs the most, that's your mode. If there's one in a set of data, that's called unimodal. If there's two modes, it's called bimodal. So you could have some that have no mode because there's so many of them. So we will look at that. So finding the mode, here again, here's our grades, just like I talked about. And an easy way to do that was to put that in that frequency table. And when we do that, it naturally comes out till we see where our mode is. So in this group of data, from what I've said, that the mode is the most frequently occurring, which grade would be the most frequent in this group? And it would be C because there's 8, right? Also, if you looked at it in a bar graph, you could tell very easily too. In this one, you can see that it's the highest one, right? The mode is the highest because it's the one that occurs the most frequently on that. When we look at bimodal, we could possibly find, look at this. We have quiz scores, and we have the 4 and the 5 are both coming out at 6, which would make it bimodal. And look at the chart, or look at the graph, the bar graph. See how that looks like that too? And you can see that those are the two modes in that. Okay, so mode is the most frequently occurring. Then we get to the median. Okay, so the median is typically, you will see as the center of the data. So when we say median, we mean that the data value is equally likely to lie on this side of it or that side of it. So if your median is up at 3, you'll see some values like 2, 1, 0 on this side and 4, 5, 6 on the other. And hopefully, and what we're looking for is that normal distribution, which we'll talk about some more, and that will be the most occurring number. And then the rest of them will come easily on this side and that side. So we also think about whether they're odd, whether the numbers are odd or even. Another thing to remember on this is to put them in order when you can, the numbers from 1 to however many there are. If the data is odd, we would say 2n plus 1. If it's even, then we're talking about 2n. So even is 2 times n, and odd is 2n plus 1. Because whenever you have that n, if you say, okay, the n is 2, 2 times n is 4, right? Which gives us an even number. But 2 times n plus 1, if the n is 2, is 2 times 2 is 4 plus 1 is 5. And so that's your odd number. So the median of a non-decreasing list of 2n plus 1 numbers, so odd numbers, is the middle number. Okay, so it's the one in the middle. And then if we have a non-decreasing number, it's the number halfway between the two middle numbers. So if we look at it, and we'll look at it in just a minute, you can kind of tell. So if there's 7 numbers, if there's 1, 2, 3, 4, 5, 6, 7, let's see what would be the middle number. It'd be this number right here, which would be a 4. So you can easily tell which one it is. But if we had 8 numbers, you would have to add the 4th and the 5th numbers together and divide by 2 to get the median in that case. So here we go. Here's your first example. Median of an odd number of data values. So here we have our data values. There's 7 of them. Okay. So here's your first table. So we would first, what did I say we would do first? We put it in increasing order. So we can't look at this and say, okay, these 7 numbers are here. The middle one is 2970. That's not what we're talking about. That's not the middle number. We have to put them in order by size. So we add the small, that's the smallest one, right? So that's the smallest one. We put them in order from smallest to largest. And so then we can look at it and say, okay, there's 7, 3 on this side, 3 on that side. Then it has to be 6880, which is the median, which is the middle of the 7 numbers. If we had an even number, remember with the even numbers, we need to add the 2 middle numbers and divide by 2. So with the even numbers, and here in this example, we've got the number of tornadoes of EF2 or higher, which is pretty strong. If you get higher than 2, there were that many. There was 14, 9, 6, 2, 13, 3, and 1. But remember, we can't keep the numbers like that. We have to put them in order from smallest to largest. So when we do that, we have it in the correct order: 1, 1, 2, 3, 6, 9, 13, and 4. We have an even number, so we don't have something just directly in the middle. So we have to look at the two middle numbers. And what are they? They are 3 and 6. So if we add 3 and 6 together, we get 9. We divide that by 2 is 4.5. So the middle number, or the middle point of the data, is 4.5. So if we have the frequency distribution, we can also find the mode and median if we have that. And it's basically the same way. We find the mode number of women in statewide elective executive positions and the median. So we look at the highest frequency, and there's 6. So how did we get to that? Let's see, we got those 3. So the two middle numbers would be the median. And we are looking at figuring that out. We would figure that because there are 50 states, we have to look at the 50th percentile. So at least half the numbers, and we look at the midpoint of the data. So we are looking at the midpoint. The median would be halfway between the value for the 25th and 26th states. There's 10 states with 0 female executives, 9 with 1, and 17 with 2. So the 25th and 26th states both have 2 female executive. Thus, the median is 2. Okay, so you're looking at halfway between the different 50 states. And so back again, when you look at the mode, there was 17 states that had 2 women. And so that's where you get that the mode was 2, because 17 was the highest number for the frequency on that. So that would be your mode and your median. So the next thing, so we have the mode, which is the most frequently occurring number. Then we got the median, which is the middle number, right? What falls in the middle? The mean is the average. So we're going to get the average of the group of data that you have. Again, we kind of talked about it could be like your monthly electric bill. And when we do that, it's kind of interesting, though. You can get an average, but then again, if you think about it, especially like in Alaska during the winter, we spend a lot more on our electric bills in the winter than we do in the summertime. And so it just depends on how you want to budget. And the electric company can help you with that. If you want to do that, they can look at the difference. You can either pay that little, I don't know, $40 a month during the summertime, and then $800 during the winter, or they can take an average of that and you would pay the same amount all throughout the year. And that way that it makes it easier to budget. So you're not paying, $800 in some months, but then you're also not paying 40 in others. So, it just depends on, what you want to look at and how you want to do your budget. So the mean is the sum of the values divided by the number of values. So this formula looks a little hard, uh, but and also your calculators can do this too. But again, we talked about um, you learning how to do these longhand as well. But all you're doing, even though the formula is there, you're adding all the numbers up and you're dividing by the amount of that there are. Okay, so again, this just talks about decimal points and maintaining accuracy and keeping as many decimal points as possible as you go along. That way, you'll get to a better figure. If you round too soon, it's not going to give you that exact amount. And we saw that too a little bit in when we were talking about pie charts and how it would equal to more than 360. So we want to be really careful when we get our numbers that they end up adding up to that 360 or a 1 or um, whatever point we're looking at. So we look at the most accurate data we can find. So when we compute the mean, we look back at that example we saw before about the tornadoes in Oklahoma, and we'll find the mean for that. So there are 8 points of data. And so in this one, we don't have to put them in the numerical order, but we're already probably going to have it in that way because we were looking at the median. So, it doesn't hurt either way. You're going to have to do it at one step or another if they ask for the median and the mean. So, that's typically up to you. So, in this set, we just left them in the order that they were given. So the mean, which is that little bitty U, kind of like a U sign. Okay, that's the sign for the mean, is equal to all those numbers divided by 8. So we say 49 divided by 8, and it gives us 6.125, which would approximately be 6.1. So if we look back at that and think about it, we saw that the median number of annual tornadoes was 4.5. And that's a lot smaller than the mean of 6.1. So that's a big difference. So what do we say? Do we say that the median or the mean is a better set or better representative value of that group of data? So I guess it really depends on what you're looking at. I mean, you don't want to mislead people, of course. I mean, we go back to that misleading graphs and stuff. You could give both sets and then explain, or you could give the one that makes sense to the most people. So in this example, it says, suppose we are considering the incomes of a group of people. If we're talking about pooling the incomes, as in the case of a family, then the mean, which is the average, is most relevant. If we're talking about providing government services, the median income is probably more relevant because a few individuals with high incomes can raise the mean, but the median. And so it would look like the people in the town are making more money than the representative or more of the amount. Okay, so we want to think about what looks best for the town when getting, for example, government services. Now, is that wrong? No, it's not wrong. That's the median or that's the mean. We just want to make sure, because remember, we are condensing this group of data into one number. And so we want to make sure that it explains what we want it to say. And so we want it to most accurately reflect what we are looking at. And if we do that in this example, then the median was more appropriate. If we have a frequency distribution, we can also figure out that mean if it asks for the mean of the frequency distribution. You're saying the frequency. Okay. So if we have this example, so we had the one about the 50 states. And so our formula would look like that. So we're multiplying the number of women times the frequency on that. So it gets a little more daunting, um, but then there you would get your answer. Um, so in example 5, we had, if we look back at that, we found the mode and median were both 2, and the mean is 1.9. So we're a lot closer on that one. So in that case, you could use probably any of the data numbers. The mean, median, or mode, and it would give you the same data. So if we have group data, remember how we grouped it earlier, and we tried to figure out how to group it best. So depending on how we group it, we're really estimating the mean based on what the group looks like. And so you can also go through and figure out an estimate of the mean by looking at the intervals. So hopefully we won't have a lot of those to do, but um, there's the solution on how to do that. So, but what you're doing is you're trying to find the middle number in that interval, and so you're saying 11 minus. We say 11 11 to 11.9, sorry. So we're saying 11 plus 11.9 divided by 2 and getting that middle point. Again, it's an estimate, so we're estimating what, the value will be. So it's gonna be close, but that's the best way to figure that out, and in this example, we got 16.45. And think about that as we do the mean, we have to also, when it's because of the frequency, you have to use the 2 times that 11.5. Now, you could say, for example, you would make the list a lot longer, but you could say 11.45 plus 11.45 plus 12.45 plus 13.45 plus 14.45 plus 14 point. See what I'm getting at? You know, you could write them all out that way. But in this way, because we have the frequency, we can multiply the numbers by 2, and it makes it a little simpler, especially in this one when we get to 14. That's kind of hard to add all the 15.45 times or plus that 14 times. Okay, so then here's your answer, and you get 16.45. So that is your section on typical and central values. That was not so much, not so intensive, although um, there's a lot to know on that. But hopefully, you know, that's something that is a refresher for you. Mean, median, and mode. Um, mean, um, as we go back, close chapter. Mode, of course, was that um, most frequently occurring number, right? So, or grade, as in that. So that's the most frequently occurring number is your mode. And then, and remember, we can have unimodal or bimodal. It might ask you that question, but that's for what you would need to know that for. The median is the center number or the middle. Think of it as the middle. Remember, if we have an odd grouping of numbers, there's so many on the left and so many on the right, and whatever's stuck in the middle, that's your median. But if you have an even number, you can't do that. You have to add the 2 middle numbers and divide by 2. Remember, it's important to have those in numerical order. So from the smallest to the largest to get that. Okay. So make sure that that's part of something that you remember. And then we talked about the different things with frequency. And then the mean being the average and adding them all up and dividing by the number of data points in the data set. So there's your mean, median, and mode. Let us look at, remember, if you have any questions, please don't hesitate to reach out. Take notes as you're going along. Stop it as you're going along. See what you might need as you're going along, and I will, you can get with me in questions after that, after. So next, 3.3, measures of spread. So we want to know what this, how many measures are in the middle, the range of the numbers. Where do they fall from? What's the smallest one? And what's the largest one? So we're looking at the range, the difference in the values. So basically what we're doing, of course, we want to set it up right in numerical order, right from smallest to largest. So we're going to say the largest value minus the smallest value is going to give you that range. So if we had the gallons of gasoline, the average prices, then we want to make sure, and it looks like this one is already in numerical order for you. So that's good. You don't have to re-put it in there. But then we would just say the 3 point, oh, it's really not, because I thought it was at first, but then I'm looking through it and I'm seeing, oh, they tricked us at the end. So 3.49 minus 2.42 is 1.07. So that would be the range of that set of data points. So the range measures the spread of the distribution. So the maximum spread. So the numbers are going to be within that and that. The standard deviation is giving us a representative sample of a distribution. So when we look at that, we need to compute, or we need to calculate each by the mean for each I, which is called the deviation from the mean, or how far each data point is from the mean. Okay, so of course we have to find the mean point, and then we have to figure out, okay, how far is that from the mean? So our little symbol for standard deviation is this little bitty, a lowercase sigma. And so then the formula looks, again, really daunting, but you're taking each data point and subtracting it by the mean and squaring it. And when we square it, we make sure that that number becomes positive, because when we square, the number always becomes positive. And then we divide it by the number of data points. Again, you got that in again. So you're looking at the total number of data points, but you're also looking at each data point minus the mean squared. And you're also taking the square root of it. Oh, goodness gracious. Okay, here we go. So we're going to look at, first, we're going to look at this group of exam scores, and it's a small class, so we're going to get away easy this time. So we're going to find the mean and the standard deviation. So of course, because we want to find the mean first, because we have to have the mean to be able to figure out the standard deviation. So we add all the data points together, divide by the number of data points, which is 6. All right, and we get 78.5. Okay, think about it. Let's go back. Is there a mode? Nope, because each occurs once, right? Let's see if we put them in order. What would be, let's see, it would be 70. So we're going to take that next step. We're not asking for this in this one, but I mean, we're just trying to see if we could know what it is. 73, 75, 79, 80, 81, and 83. We know we have 6, so we know we have an even number. So we have to take the two middle numbers and add those together and divide by 2, so we can find the median, or the middle number. So in this case, it'd be 159 divided by 2. We would get Make sure you carry the 1, 9. So about 79.5 would give us that um, median. And then when we look at the mean, it's interesting. It's really close at 78.5 as we did that. So there's how, again, doing the mean. So to find the standard deviation, and again, this will be on your calculator. You can use your calculator um, to get these, but I also want you to know how to do it in case you need to, or in case your calculator is, who knows, somewhere on the fritz, or you know you just want you just thought it would be interesting to create to figure out this math problem in longhand on your own. I know, never, right? Okay, so I get the standard deviation is we've got each of these data points, and we subtract each of these by the mean that we found. So we say 75 minus 78.5 squared. Now remember, we have to do these in order too, so make sure that you do everything in parentheses first. Okay, so you're going to get negative 3.5 squared. So remember, everything is going to come up positive, and we get the answer 3.45 is our standard deviation. Okay, so we want to do that again. But here we're going to compare them. We're going to compare the mean and the standard deviation. So that's our next step. We get, again, 78.5. We did the formula to figure out the standard deviation. So we got 24.92. So in each case, those 6 exam scores had a mean of 78.5, but the standard deviations were a lot different. The standard deviation was more spread out, and those are the ones that had the larger standard deviation. Just something to look at in understanding different points of data. We can do frequency as well if you have a frequency distribution. And so there you're just adding the frequency portion of it on there as well. And the rest of it comes up to be the same. But remember, when we have that, we have to say that we know 55 happened 11 times. So that's why we're including that 11 in there when we do the mean and when we find the standard deviation. So look at those and see where I'm seeing that, the 11 times the 55, which came from this grouping right here, 11 times the 55. And then carrying that over when we get the standard deviation. Okay, that we know that it's 11 times that we have to do this. Again, like I said, you could write it out 11 times. You could write the 55 minus 65.5 squared 11 times, but you don't have to. So that's the great thing about this is you can do that. And then again, of course, if you use your calculator, then it makes life easier. Or like an Excel spreadsheet. Again, we can do it on group data too. And we can figure out on this example, it's point margins using the standard deviation. So I guess that's how they figure out gambling stuff, I suppose. Not too into gambling, but I just watch sports for the joy of it, not to try to figure out the spread and but that's all of this. That's all the spread and the midpoint and the standard deviation and all of those trying to figure out who is going to win a certain game or not based on the statistics from a previous game. So if you're really into the gambling or you're really into figuring out who's going to win and talking about that, then that section was definitely for you. So we are going to head on to And I talked a little bit about this before. You heard me say the normal distribution. I think I also said a bell curve at one point. So that's what we're going to look at in 3.4 is the normal distribution. Now, give me a second to